see.
A week from today?
Yeah. Because you'll probably more likely go to practice exam.
Want me to take notes?
Please.
All right.
And if I give you my email or my cell phone number.
I can send you
Email?
Yeah. Either way.
Okay.
Not a problem.
I appreciate it.
No worries.
Thank you.
You should probably wait till Monday because otherwise I might get I have an ACT Saturday.
Okay. Is it a retake or?
My first one, I did wrong. The second one, I did 1 point first one.
Really?
Because I haven't been in school like every summer.
Uh-huh.
And then I'm taking this one, but then last time.
How many times are you going to take it?
You can do it.
Okay.
My first was 7.
Oh, wow.
Is it like freshman year?
On. Oh, wow. Wow. Right? I'm terrible with this too. I get all nervous. You see me sitting here chewing on my fingers and bouncing my leg.
It's like a problem. I think about it. I don't have to know if I can focus. It's like focus.
Next, it's Monday after I come out. Not next week. The week after.
I thought. So, because next week I actually finish the test.
Mm-hmm.
And if I math that,
Would it just
on the spot.
I hear you. I'm a little worried about this.
This test. I have one of my friends took this class.
name.
It's better than some.
Sure. That's not real bad.
I mean, considering like their median salary after graduation is terrible, it's like their median salary after graduation is $5,000. So like, you can pay it off if you go to get a job.
It's just so true. Can I see it? Did I ask you to like, what is it? Or to sign up? Yeah. What are you didn't hear it. Don't worry, we're going to try next year.
What?
Yeah.
37.
So 30/70 is 39 years. So like, you know, so are they making it available? Anytime we have a short people, see, I'm your sister. I'm so used to just kind of like everybody else. Right? I agree. Yeah, some people have a bad one. I don't have it. I feel both of them are
Megan. Here. Elsa. Here. Morgan. Here. Allison. Here. Katie. Here. Mia. Here. Catherine. Here. Curtis.
Here.
All right, let's continue set theory. Today I probably am trying to say, by the way, the practice exam, you can cross out, practice exam 2, you can cross out the last maybe 3. Let me take a look. All right, on the practice exam, you can cross out the last number 13, 14, and 15. So we won't have them on the second exam. Okay. And it will cover up to today's class. So next Monday, if you have trouble doing this practice exam, I can give you more examples and next Monday, and maybe you can turn it in later during the day. Okay, so the main province on the second exam will be proof province. And I'm trying to think. If I'm going to finish chapter 5 first. If I have time today, I may give you some hints about every proof province there. Okay, so let's continue. 5.1. We have one more concept left. We talked about those 5 operations last time. Definitions. But we're almost finished with 5.1. The last concept definition we're going to talk about is called a power set. Power set definition. Power set, let's say A of A is given set to A. We use a symbol, kind of like the P, the first letter P, but it's sort of like cursive, but I guess it's not exactly cursive letter of P. It's not. So power set. The definition is all the subsets of A. It's the set of all the subsets. A set of all subsets of A. Give you an example here. First of all, the power set is also a set. And whenever you see set, it should be, you have curly brackets. Let me just start with the example. A, we have maybe A and B, 2 elements in there. Okay, so now go back to think about the definition of subsets we talked about before. So previously, we had questions like given 2 sets, and you were asked to determine whether one of them is a subset of the other. Did I switch back? I did. Okay. So, for example, we looked at those. We used the definition of subset. We determined that A is a subset of B because every element of A is also an element of B. 1 is the element of B, 2 is the element of B, 3 is the element of B. So that's why that's why we found out A is a subset of B. Okay, but now we are given a superset A. You're supposed to list all the subsets of A. Okay, so can you come up with any set that is a subset of this A? Just the A, right? Okay, so James said, okay, we can have a set with only just A in there. And apparently that's a subset of A, right? Because every element, well, we only have 1, so that's the element of this set, James said, is a subset of A because, maybe I can use this symbol here. is a subset of A. This is A. Because the element is in AB, the set of AB. Now, anything else? B, yes. So Austin said we can put a B in that set. And yes, that is also a subset because B is in there. Well, anything else? AB, yes, okay. AB, in fact, it is equal to the set A, but it's also equal, can also be considered as a subset as long as it meets the definition. Because the definition says every element of the subset should be in the superset, which is true. A is in here, B is in there. So the set of AB is a subset. There's one more missing.
BA?
Well, BA is the same as AB. I mentioned this last time very quickly. When we use curly brackets, the order doesn't matter. So when you have A and B, apple, banana, and banana, apple, they're the same thing. Okay, there's no order when you talk about sets. I mean, in high-level math, we do have ordered sets, but right here, usually lower level, we consider whenever we see curly brackets, A, B, and BA are considered as the same thing. But if you talk about parentheses, A, B, and BA, they're not the same thing. And 1, 2, and 2, 1, they're not the same point. If you remember the example at the end of the last class, A, B, and 1, 2, and 2, 1, there are two different points. But if you talk about sets, let's change the parentheses to brackets. Those don't mean points anymore. It just means, okay, I have a group with two numbers in there, a set with two numbers in there, 1, 2, or 2, 1. But they will be considered the same. Okay. So we so far we found three: a set of A, set of B, and set of AB. Well, you can say BA. Well, there's something I haven't talked about, haven't mentioned, or have I? I think, did I talk about this? What if you have a set without anything in there? We call it empty set. I forgot if I introduced this or not. So we also have a symbol for that. Pretty much you just write down two curly brackets with nothing in there, with no elements in there. We call it an empty set, which has which does have a short notation that can be written as sort of like a zero with the line through the zero. So I did notice some students use this to represent a zero, right? But in fact, in math, we use this for empty set. But this empty set is also considered a subset of any set because empty set has nothing in there. Well, it automatically considered as a subset of any set. Okay, so these are all the possible subsets we could have found. So usually when you do this type of question, follow a certain order. You can start with no elements. You can always start with the empty set. You can use either of these symbols. If you want to write down two curly brackets, you can, or just use like a quick symbol for that. And then you try to list all the subsets with only one element. Look, this one has 0 elements in there. 0 element, and 1 element. We got 2 of them. 1 element. And with 2 elements. And that's all. So how do we write down the answer? The answer will be, when you do the question, you don't really need to show me all the work here. All you have to do is to give me this. So what is, example, let me write down this again. What is if they ask you to find the power sets of A, first of all, you draw a big curly brackets. Well, if you want to wait until you finish listing all of them and put curly brackets later, you can. But right now, I'm just going to write them down to emphasize this. Remember, power set is also a set, so it itself should be a set. And what are the elements in there? You could have. All right, let me start with the empty set. Sorry, empty set with nothing in there, comma, that's the first element. A set with one element. A set of A with set of B, and a set with two elements. Okay, and that's all. Each of them is a subset. That's a subset, that's a subset, that's a subset. Pretty much the one we found. So you can see you have curly brackets inside curly brackets. Make sure you don't use parentheses for these, because parentheses, subsets is also set. You have to have curly brackets. But parentheses, that's not set. Let's go over the Cartesian product one more time. We did at the end of the class. This is what we had. Cartesian product, you need to have two sets, set A and set B. The definition is, it's like points, using all the elements in A as your x coordinate, all the elements in B as your y coordinate to form as all the possible points you have. So you could go ahead 1, 1, 1, 2, 1, 3. So you got these 3 points. And 2, 1, 2, 2, 2, 3. We got these 3 points. 2, 1, 2, 2, 2, 3. And notice that we're not supposed to use curly brackets for each point. You're supposed to use parentheses. The word doesn't matter. So the biggest difference is Cartesian product, every element is a point. 1, 1. That's a point. That's a point. How many points do we have in this set?
6.
How many?
6.
Say it again. 6, right? Yes, we have 6 of them. Another thing is, if I ask you how many elements are in this Cartesian product, how many elements in this set? Same thing, 6, right? 6 points are 6 elements. Please don't think each of them like this is it. One itself is not an element, because the element of a Cartesian product has to be a point. So these two numbers together, 1, 1 as a point, is an element. That's an element, that's an element, that's an element. So we only got 6 elements, although we have 12 numbers in there, but we only got 6 elements. And so again, each of them is a point, which is also called an element of the set. And over here, power set is completely different. The power set, we have 1, 2, 3, 4 elements. Each of them is not a point. Each of them is also a set. So we got 5 elements, which is also 5 sets in there. Okay, so we could have this concept called set of sets. So elements of a set is also a set. And in real life, we do have this kind of situation. For example, math club is a set. It's a concept of sets, very similar. So for example, math club, say we have a few students, say Elena or James. And then we have a history club. We have Danielle and Austin and maybe somebody like Mary. And then we may have another education club or psychology club, whatever that is, and you may have a few other students, say Cody, maybe let's just put one there, Cody. And then each of them is a set. But suppose that's all the clubs we have on the campus. And then when I say, okay, when I put all three of them in another curly brackets, we got an M, H, E. Well, notice that this is the set of all clubs. Each club is also a set. So this becomes the set of sets. Okay? And, well, math club is part of this, is an element of all the clubs. And history club is also a member of all the clubs, and the education club is also a member of all the clubs. Okay, and so this is something kind of similar to power set we just talked about, but why we have set inside of sets. In real life, we do have kind of this set situation. It's kind of like saying group of groups. Okay. So after we introduce this, we got to kind of go back to look at the symbols we talked about before. These two symbols. the first homework question is asking to distinguish between these two symbols, and I can give you some examples. So without the new situation we have, the set instead of sets, it should be easy. I think everybody knows. For example, when I give you, I think I can use this as an example. So E and M. E is the student Elena. M is math club. Which one of the symbols should I use between them? E, the first one or the second one? The first one, right? It's because why do we have to use the first one, not the second one?
Because she belongs to the math club?
Yes, that's right. She belongs to the math club. Math club is a set. She's just a member of it, right? She's a member of the math club. But if I give you, I guess we don't, let me maybe create another one, psychology. Let's do psychology club with, biology club with two students in there, Danielle and Austin. Okay, so now let me give you two questions to compare. So what should be the symbol for biology club and the history club?
Second one.
Second one. Why?
It's a
Because
subset.
it's a subset concept. Well, when you look at B and H, they're both sets. B is a set. Let me write down the whole set to compare them instead of the symbol. So that's B. That's biology club. That's history club. When you compare them, as you can see, they both have curly brackets. And the member of biology club, Danielle and Austin, they're also members of the other one. So notice that they are inside curly brackets, so we use subset. But if I write down M, it's Elena and James. And look, Elena represents herself, not a club. Okay, so she is only a member of a club. So you see the difference? Elena, look at over here, we don't have curly brackets. But what if I change, let's say, okay, she's going to go for our psychology club. Just right now, we only have one member, that's Elena. And compared to math club, so now when I put curly brackets, add curly brackets to E, she does not represent herself anymore. This represents what? The psychology club. But if I don't have curly brackets, she just represents herself. So she's a member of math club. But in this case, what should be the symbol? First or the second? Subset, right? Okay, because as a set, that not her, the inside, the psychology club's member, Elena, is also a member of math club. Okay, so be careful about this. Now, when this get confusing, it's like the case we just discussed. What if we have set inside of sets? Okay, say, for example, we have math club. Let's see, math club would be EJ, and then we have another one which has EJ and biology club BA. Now compare these two. What's the symbol I should use, first or the second?
The second?
The second?
No, the first.
The first. It should be the first. That's when it gets confusing because previously, since very easy, we can find a pattern. Okay, well, if one side does not have curly brackets, it should be a member. And then we always use the member symbol or the element symbol belong to. But if both sides have curly brackets, they both represent sets, then we should use subset symbol. Well, it does not always apply when you have curly brackets, but once on one side, inside curly brackets, you also have curly brackets. And that will, you cannot apply that pattern anymore. So in fact, when you have two sets, it may not always be a subset. And in this case, it's actually a member. Why? Because now you have to, because we have set inside of sets. We do have another name to call that a set of sets. Sometimes we call them a collection. You have a collection of sets. This is another, like a bigger set. And inside them, each member is not an individual person. It's a club. It's a club. Each set represents a club. So this one was what we called before math club. And this one's biology club. So if I put math club and biology club in the set, so this is like this collection, or this set of sets means it's the set of math club and biology club. On the left-hand side, it's math club. So apparently, math club is a member of the collection, the set of these two clubs. Well, the easy way, kind of like a tip to help you do this type of question is, when you look at them, the whole thing, including what? The curly brackets, are inside another set. The entire thing are in there. It must be a member. Okay, just like what we did before. See, E, the entire thing, E, is inside of curly brackets. That's called a member. Because Elena, as an individual person, she is a member of math club. But right here, the set of these two students, Elena and James, so they represent the math club. The math club with the curly brackets is a member of those two clubs, the set of two clubs, math club and biology club. Okay, the entire thing is included in there. But suppose, let me change this a little bit so you can compare them even better. I have these two. Okay, give you these two questions to compare. Let me get rid of the other club, the biology club. Just leave math club in there. Okay, two questions here. Question 1, question 2. Now, what should be the symbol for the first question? And what's the symbol for the second question? Subset. First one is? Huh? Belongs, right? Belongs to that. Okay. Well, the only difference you can see is this pair of brackets with that. That's the member. So it's like, okay, I have a set of clubs. I'm going to try to, try to find the set of all the clubs here on our campus. Unfortunately, I only found one. That's all we have. We only have this one club, math club. We don't have any other clubs. And then you will have to say the math club is the set of all the clubs. Okay, it's a member, belongs to the set of all clubs. Like the tip I gave you, the whole thing, including curly brackets. So that, think of the whole thing as one entity. It's like a club is a member of another, the set of all clubs. But in the second case, well, it's only the inside member, E, Elena, is a member of the set, not the whole thing anymore. So if you take the whole thing, we don't have anything inside of another pair of inside. If you look at the inside of the members of this pair of curly brackets, you only have E and J. But what's the members here? Set of E and J. Okay. Let me write this down here to emphasize the difference. So the big difference between these two is the member we can call element. The member or element. What is the element in this set? the math club with 2 students, including the curly brackets, what's the member or element of that one? Only E and J without curly brackets. Okay, so whenever we talk about member, you have to get rid of one pair of curly brackets. So the member, I get rid of them, I still have another pair. So that means the member is another set, which represents the math club here. But when I get rid of one pair of curly brackets, I don't have curly brackets anymore. Each one is an individual person. So that's the main difference. Okay? All right. So in that case, if the entire thing is in there, in another pair of curly brackets, you use subset, the element symbol belong to. And otherwise, you're going to use the two sets, the subsets symbol. So that should help you do the homework question. The first those questions here, number 8. Okay. All right. Any question about these 2 symbols?
Yes. For number 8, the one that we were just looking at, for ones like B and E, where the
number E.
Yeah, B and E, just any of the ones where the first one is not in brackets, but the second one is. How do you tell the difference between the symbol in the middle, if that makes sense?
B and E, right?
Yes.
Okay. So I can also use the example we just discussed here to explain. So the question in the homework is part B. That's one, and part E. And so the concept we have, if you remember the tip that I gave you, okay, on the left-hand side, if the entire thing is included in another pair of curly brackets, it's the first symbol, belong to. If only the inside of curly brackets also in another pair of curly brackets, that's subset. So we can look at the example that I gave you, Elena compared to math club, and Elena compared to math club. Oh, well, it's pretty much the same question. It's just like which one is the right symbol. So in part B, they use the subset symbol, and in part E, they use the belong to symbol. So which symbol will be the correct one when we talk about an element? E is an individual person, just like 1 is an individual number. Whenever you put a curly brackets around it, it does not represent 1 anymore. It represents something. So in real life, probably, like for example, I don't have to put a James in there. So if we only have she as only person. Okay, it's possible. Math club only has 1 person, 1 member. It's just Elena. Okay, and so when I compare them, when I put the difference, without curly brackets, she only represents herself. With curly brackets, what does this represent? Math club. It does not represent her anymore. So when you compare them, what's the right symbol? Let me write down the definition. Don't look at the E, just write down this. When you have a set, you always write down the member or elements. So what's the element or member of the set when you look at the set? What are the members? Can you tell what the members are in this set? E?
Yeah.
E? Yes. Only 1 element, E, right? When you look for the member set, very easy. Get rid of 1 pair, the most outside curly brackets. So when you get rid of them, you got E. And so what does this mean if I write it down? E is a member or element. Member of the set of E. Whenever you see the word member, what does that mean? What symbol do we use? That's the symbol for member. Okay? And the other symbol, what's that symbol? That's subset symbol, not a member symbol. That means subset. So in this case, if I write it down, when I get rid of 1 pair of curly brackets, the member of this set is E, and which is E. So E, if you rewrite it, E is a member, so which means I should use that symbol. And why cannot we use that symbol? When can I use this symbol? When can I use this symbol? How do I change that? If I put another pair of curly brackets, and when you compare them, and again, when you add curly brackets, that's not an individual person. This does not represent Elena anymore. It represents some club. So maybe this is math club, and that is history club. That both clubs have the same member, Elena. So history club is a subset of math club. And when you think of, if you don't use real life meaning, again, the member of this one is Elena. The member of that one is also Elena, right? So every member of history club is also a member of math club. That's subset concept. If a member of the one set is also a member of the other set, we call that a subset. So that's the definition of subset, which I think when I gave you the definition, I used the word element, but element just means subset. It's the same thing. All right. Do you need more examples for this?
No, I think I got it. Thank you.
Okay. All right. Now, let's, any other question? Okay, so next, homework number 27A is combining the last two concepts we discussed. So when you do 27A, break it down into two steps. Now, I'm going to try to do a similar example to this, so that will help you to do this question. So A, I'm going to use, I can use the letter B. I'm going to use a number, maybe 1 and a 2. This is a little different, but the idea is the same. The question is to find this P means power set of A times B. So it has two operations involved. Which two operations do you see here? Yes, there's a product that you have to do. And after that, then you do this P. What does P tell you to do? Power set, which means all subsets. You got to list all the subsets, right? So break down into two steps. Step 1, I'm going to do the product, A times B. And remember how we do A times B?
Break it up into points.
Yes, it's like 4 points. What points can we get in here? A comma 1, A2. That's it, right? Okay. So remember, you have to fix the order. The first component, we can call it X quantity. It has to come from the first set given. And the second has to come from the second. Okay. Now, that's the first step. Step 2, I'm going to do power set. Okay, power set means all the subsets. The one we did before is a little easier. But I said follow a certain order. Usually you want to start with a set with no elements, and then a set with one element and 2 elements. You can at most, so A times B, how many elements are there in the product set? How many are in here?
2.
2, right? Be careful. Only 2, no, not 4. Okay, because these 2 together is considered as one member. And again, maybe using the idea of calling it a point is easier. So that's point 1. That's point 2. There are 2 points in the product set. So it's if you remember, the product set means a point on the XY plane on the plane. That should be helpful. So now we're going to list all the subsets. First of all, a set subset with no elements, that would be an empty set. It's always in a power set. Now let's list a set with 1 element, 1 member. which is 1 point here. So we got 2 points. See, 2 points. So I could do first point, A1. And that's just a point. How do you make it a set? Curly brackets, yes. Again, if you go back to look at the definition that I wrote down for power set itself is also a set. So you will have set inside of set. And you also have parentheses. So that's what makes this question very complicated. You have parentheses to represent a point, and you have curly brackets to represent a set. Okay, so similarly, we can take the second point and put in a set. So that's the second point. That's all. We could also have 2 points in a set, right? So that will be one more. I'm out of space here, so I'm going to put it right down here. So in the next one, we put 2 points in there. First point, second point, and curly brackets. And then there's another bigger curly brackets to finish the power set symbol. Now take a look. Why do I have this pair of curly brackets? Because, yes, this represents the power set, because the power set is also a set. That's why these two are for the power set. Now look at the inside. We have 4 elements, 4 members. Why is each of them 1, 2, 3, 4? Each of them is a set. That's a set, that's a set, that's a set, that's a set. Curly brackets. Although this one you don't see curly brackets, this is the same as, when you write down this, it's the same as writing down 2 curly brackets. Just say, it's a little easier. If you say, I don't know the symbol, you can certainly put 2 curly brackets there without anything in there. So each of them is a set. We got 4 sets. And look at each set. The first one is an empty set. It has nothing. The second one has 1 point in there. The first point. The third one has 1 point, the second point. And the last set has both points in there. Okay. Any question? Okay. The reason we talk about power set is later we talk about counting province. It kind of uses this idea of, and also Cartesian product. It's also one type of counting province later. After the second exam, we're going to talk about counting. Well, I think on next Monday, after answering your question about the practices, and I will talk about chapter 6, counting province. Okay. All right. If you don't have any more questions, we are going to look at the proof province, which is probably the most difficult part in this section, this chapter. So 5.2 and 5.3, we're going to put them together. 5.2 is doing elemental argument. 5.2. Now, if you look at the textbook, properties of sets, it listed a lot of properties of sets. Inclusion of intersection, inclusion of union, transitive property, and on the back it also has a lot of properties. And on page 272 it also has like commutative property, associative property, distributive property, and a lot of them. But we are not going to go over every single property. We're going to take a few of them and to explain how we prove those properties. I think in statistics we do use some of those properties, but here we're going to talk about how to prove property. So before we do the proof type of question, we need to go over the definitions again. Most of the questions that you have to do is to prove either the first type of question is to ask you to prove if a set is a subset of another one. For example, I'm going to use maybe X and Y. So set X is a subset, prove set X is a subset of set Y. That's one type of question. The other type of question, maybe leave maybe 1 or 2 lines here. So I write down how you do that. Second type of question is to ask you to prove 2 sets are equal. set X is equal to set Y. In order to do type 2, you need to know how to do type 1. So let's look at type 1. How would you prove a set is a subset of the other? Definition. Okay, you're just using definition. What's the definition of subset? All element of X, yes, is a, let me put 2 lines to emphasize this capital letter A, but this X is the lowercase x, capital letter X and the lowercase x. So you need, the definition says every, if you remember on Monday, I wrote down both sentences and symbols. And I said because it would be easier for you to memorize it in sentences. But when you do the proof, you want to use symbols. So every element of D is an element of E. In our case, we're doing X and Y. So every element of X. That's what I say when I memorize it. That's how I memorize it. But when I write it down, I immediately change it into symbols, the words to symbols. So for every element X in the set X, the element X is also a member in the set Y. If those 2 X's confuse you, maybe we can change it to A instead of using X. Because when I say X and X, there are 2 X's. But these 2 X's are different, so let's use A, maybe not too confusing. So for every element A in set X, A is an element in Y. That's the definition. All the proof questions you're going to do, you will have to use this constantly. It seems very easy, but the questions, take a look at the homework question, for example. This one, the second one, you want to prove the intersection of A and C is a subset of intersection of B and C. Well, will be our X. This will be our Y. So it's like you're trying to show every element of A intersection with C is also an element of B intersection with C. That's why you need to show by the definition. The other type of question, as you just saw in the homework, how do you prove 2 sets are equal? How do we prove 2 sets are equal? So let me give you 2 sets here and an example, and I want you to check. So this is my X and Y. Are these 2 sets equal? Well, what does equal mean? It means they have exactly the same members, exactly the same elements. Are they equal? Yes. How do you know they're equal? The order doesn't matter, and also how do you check it? How do you show, how do you explain that they are equal? And 4, right? See that? Okay. So I verify they have exactly the same. 1 is in both, 2 is in both, 3 is in both, 4 is in both, right? But when you really do the proof problem, you cannot see what are in there. Look, take a look at the homework question. It's not as easy as the one I just did, because what's given? You're given a set A. It's any set. You don't know what's in there. And the same here. You don't know what's in the other one either. Right? So how would we prove these 2 sets are equal? Okay, so go back over here. So this is what we do. We start with one of them, X, trying to check every member of X is also a member of Y. So Y is in Y, 2 is in Y, 3 is in Y, 4 is in Y. After I check that, what does that tell me? Every element of X is also element of Y. What does that tell me? Yes, that's right. X is a subset of Y, right? But would this guarantee that they are equal? No, because I can add an element here, 5 here. Every element of X is a subset of Y. Y is in Y, 2 is in Y, 3 is in Y, 4 is in Y. But they are not equal because Y has an extra element, right? So if you check it backwards, 4 is in X, 1 is in X, 2 is in X, 3 is in X, and 5 is not in X. That's when we realize they're not equal, right? But let me get rid of 5. If I get rid of 5, I found out every element of Y is also element of X. What does that tell me? Y is a subset of X. When we have both, this will guarantee what? That they are equal, right? Does that make sense? Okay. So how do you check whether two groups have exactly the same students? You can start with one of them to check, okay, every student in the first group is also in the second group. But the second group may have more, right? Have more students. So if you check backwards, also, every student of the second group is also a student in the first group. And that tells you that they have to be equal. So in order to prove that two sets are equal, you got to do two subsets proof. That's why I said the second type of question. In order to prove two sets are equal, you have to do type 1 twice. So you got to prove X is subset of Y, and also Y is a subset of X. So that is how you prove it. When you do any proof question given, follow what I gave you here. But also, if you want to continue, how would you prove X is subset of Y, which is type 1 there? You prove every element of X is also element of Y. And how do you prove Y is a subset of X? How would you prove that one, the second part? If A is also in X, right? That's the definition of subset. So you are repeatedly using the definition of subset to show Y is a subset of X. Every element of Y is an element of X, which means every element A you pick, every element you got to use a letter to represent A, arbitrary element, and A is also in X. Okay. All right, so make sure you copy down this, because when you do the proof questions, that's what you're going to refer to. So now I'm going to give you an example. Like I said, the textbook has like, let's see, really like 12 plus 8, 22 properties, and I'm going to do maybe 1 or 2 of them. We are going to start with I'm going to do a very easy one. Then I'm going to do a very difficult one. The one you're going to get in the proof will be the easy one. Okay. So, let's see. I'm going to do inclusion of, because I think, union. Okay, so I'm going to do the intersection. One of them is intersection. This is a property in the textbook. It's called inclusion of intersection. So it says for all sets A and B, we want to prove the intersection of A and B is a subset of A. Like I said, this problem is very, very easy once you understand it. The problem I solved in the past is students have trouble writing down the proof. And so, again, trying to imitate at the beginning. Okay, so this is the first type of question we had. Trying to prove one set is a subset of the other. Which set is a subset of the other? That's your X. That's your Y. I mean, I use X, Y, so they can be different from what we have most of the time. Because usually in textbook, they use A and B to represent sets. But you can say, to make it easier, you can call That's the left-hand side set. That's the right-hand side set. Instead of using symbols, maybe if you get confused by the symbols. So how do we prove one set is a subset of the other? Go back to refer to the definition. That's the definition of subset. So in this case, this is our x, set x. This is our set y. So what do I need to prove here? What do I need to show here? Yeah, but how would you show it's included in A? What we're supposed to use is called the element argument, which is exactly what this is. Okay, so this is called an element. We do have a name for the element argument. And this is the way you have to do by using the definition, element argument. How, again, look at the definition. How would you prove set X is a subset of set Y? We prove every element A of X is also an element of Y, right? When you see this symbol, it means element or member. Okay, so go back here. Try to apply that definition to the question you have. So this is like doing what? What do we need to show here? In words, you can use words before you use symbols. Does anybody know? Mm-hmm. Yes. Does anybody else know? What do we need to show here? How do we show subset? This symbol means subset, but how do we show a set is a subset of another? And what James said is correct, but anybody else can try it? Try to tell me this in sentence. Or do you all have trouble? Curtis, do you know what we need to prove here?
Not really.
No?
Are we trying to prove that A and B is a subset of A?
Yes, that's right. We're trying to prove this symbol means intersection. We're trying to prove the intersection of A and B is a subset of A. This is always true for any A and any B. That's right. That's what we try to prove. But how do we prove that? By the definition or element argument. That goes back to the definition of subset. Go ahead.
That all x's that all elements in A and B
Yeah.
for I don't know, I'm lost from there.
Okay. That is the first part is right. Okay, what you said is on the right track. So it looks like I think probably the big problem is the definition of subset. So what is? Can you repeat the definition of subset? What's the definition of subset?
A set A is a subset of set B if and only if every element of A is an element of B.
Right. So go back to look over here. We don't have just A and B. Don't confuse that A and B. Okay, what Curtis said is the definition that I gave you, but you do have to memorize this. Okay, you do have to memorize this. So that's sort of like consider the basics in set theory. So that's why you do have to memorize the definition. Okay, so Curtis, apply what you just said to this specific question.
But you have to prove that B is a subset of A.
Oh, you're not
equals A.
proving B is a subset of A. You prove the whole thing, this whole thing. Although we didn't prove parentheses here, you agree that this whole thing is a subset of that. Let me give you a particular example. So it looks like some of the students get confused about A intersection B, A and B. So I'm going to give you example. This A, by the way, this is not a proof. It's just an example. So A, let me give you I'm going to use any number I have. A, B is, I can do 2, 5. Okay, anything you can come up with. Now let's do those two operations. Well, only one operation. On the left side of the subset symbol is A and B. A and B, or you can say intersection of A and B. Now, what's the answer? What's the intersection of A and B?
2.
Yes. What's the definition of this? Does everyone know the answer is 2? Set of 2? What's the definition of this? It means you have to find elements not only in A but also in B, right? And then what is A? A is, I'm just copying it. So look at these two. A intersection of A and B. We got that. And this is A. Look, is this true?
Yes.
It's always true, right? Intersection is always going to be a subset of A, right? By you looking at this example, we know it's always going to be true. But the question is, you cannot use this as a proof. Because the problem says for all sets, not just these two sets that I picked, what if A is, say, A is A and the 5, and B is A, B, C, where this property applied to different pair of A and B, or there are infinite many sets for A and B. So that's why you cannot pick them come up with example. This would just be called example, not a proof. But from the example, we can tell, yes, this is always going to be true. The intersection is always going to be a subset of the original set. That's why we call it a property. It's called inclusion of intersection. But how do we prove this? You will have to go by the definition. So what is the definition of subset?
But
Let me write down.
The one I just said.
Yes, but you have to apply to, because we don't have A and B, not A and B anymore. So we are going to prove, read this, translate this into English sentence. We are trying to prove what? The intersection of A and B
is a subset
is a subset of BA. But Curtis, what you just said is the definition for what? A is a subset of B, right? So what you said is this, what I gave you in class. If you are saying A is a subset of B, but A and B can represent any sets. What we're trying to prove is not A a subset of B. We're trying to prove in this A and B is a subset of A. So you got to apply that definition to this. It's sort of like function. You plug in numbers, right? So how do you prove A and B is a subset of A? By applying that definition. A is a subset of B. The definition says, have you memorized it? If you don't look at yes? Okay, so if you have not, make sure you memorize this. Every element of what? A is an element of B, right? Okay, now what do we want to prove? It's not A, it's what?
Every element of A and B is a subset of A.
Yes, that's correct. Okay. I'm going to write this down in case some haven't seen this yet. So what we have is we're trying to show A and B, or you can read A intersection of A and B is a subset of A. It's not A and B. It's A and B with A. Okay, these two. So applying that definition to what we have, that should be. Who just said that?
I did, Leah.
Leah? Okay, so I think you all heard what Leah just said, which is exactly right. So you're pretty much replacing what? Replacing A with what? What do we have? What corresponds to A?
A intersection.
A intersection with B, right? And replacing B with what? What do we have? A. So replace this A in the sentence with A and B. Replace B with A. Okay, so let me write it down here. So you're trying to prove exactly what Leah just said. Every element of intersection is an element of A. Because the subset they want to prove, they may not be exactly A and B. They could be many different things. So in the homework, if you take a look at your homework question, look at this question here. So can you do it similarly? Can you tell me what we need to prove right here? Looking at this one. This part right here. Did I switch? So can you see what we need to prove here?
Which one?
Right here, this one right here. Proving the
A
subset.
and B are a subset of B and C?
Yes, that's right.
If
So
we
that
don't-
means,
Do you want the second part of that?
this is not the second part. This is the conclusion. That part is the hypothesis. So hypothesis is given. We want to prove. That's the one we want to prove. So in order to prove this, apply the definition. That means we need to prove what? Every element of what?
A and C is
A and C
is a subset.
is, don't use subset anymore, but then we want to use the definition of subset. You got to explain what a subset is. So when you do the proof, you're not going to go back to look at the sentence we have. So this is the
Is
sentence.
an element.
Yes, you always say the element. You don't say subset anymore because that's the definition of subset. What's the definition of subset? You keep applying this sentence. It's kind of like the formula you are using. All you have to do is to replace these two sets. Okay. So go back there. So you're trying. Can you say it again?
A intersects C is an element of B intersects C. Or
We don't say element. Go back. You cannot say that. Okay. A intersection of A and B is not an element. It's a subset. But when you prove it, what do we say? Let me go ahead and write this down then here. Maybe it will be easier for us to see. So this is what we want to prove. Although they used that whole part, they didn't use a sentence, use the symbol. I'm going to use the word to. But this is the one they want you to prove. Again, the textbook, the question, they use that symbol, but it's the same as this sentence. So how would you prove intersection of A and C is a subset of intersection of B and C? Now, we're going to have to get rid of it. What we have is not A and B again. Correspondingly, what do we have? This is the one you have, this is the one you have. So what do we need to prove again?
every element of A and C is an element of B and C.
Yes, that's right. That's correct. But don't say A and C is an element of B and C. We don't call it an element, we call it a subset. So you will have to say every element of A and C is an element of B and C. The example real life example that I gave you is, say I have a discrete math class, and then there's education class, and after I finish class and I'm working to education class, I realize, oh, okay, every student in my class is also there. So which means every element of discrete math class is also element of education class, right? It's exactly the same thing. But it doesn't have to be discrete math class and education class. It could be something else. It could be maybe a biology class and a history class. So what these will change, which is a subset of that other. So I can say my discrete math class is a subset of education class, But again, how do you prove that? Every element of discrete math is an element of education class. But of course, we don't say element, we say student, right? But in this case, we say element. So that's the same kind of concept. Okay, is everybody clear? Look at one more here in the homework, the last one. So, we are always going to look at the conclusion part that we want to prove. So can someone tell me the definition for that part? Curtis, do you think you can explain this part in definition now? So I can go back. I will just copy down that question here. We'll follow what we have.
If every element of A union B
Yes.
is an element of C.
Yes, that's correct. Okay. Every element. So look, that part is always the same. The only thing that changes is those two here. See, I just need to change those, right? Everything else. So this is the format you have to follow every single time when you prove subset A union B is an element of C. So if you all understand this, now I can go back to do the proof. Okay. So that's the important part that you have to understand. Okay, so let's look at this question here. So we are going to prove. Let me bring this up here. So that's the question we're doing right now, and these two are the homework question, homework and homework. So I'm going to, how do I prove that? That means tells me I need to prove every element of A and B, A and B is the element of A. Well, how do I represent it? Every element. Use a symbol, right? Anything. You want it, if you like X, use X. If you don't like X, use A. Anything you like to use. Usually we use the letter X. So I'm going to call this every element X. Okay, so the first step you always write down is this. Let X be an element of A and B. Okay, where did I get this from? Because that's what I need to prove. Every element of A and B. And how would I represent that every element? So later, when you do the proof, you don't have to say every element. You're just going to call that every element X. Well, I said it in a sentence. If you don't like symbols, you can use sentence. If you write in sentence, that would be let X be an element of A and B. So if you want to use sentence, you can. The papers we publish in math, we accept both. You can, of course, use words, but you can also use symbols. So this is usually the way I'm going to do, because it's much quicker. And what do I need to show? So I start with the element of A and B. I need to show that element X is what? Is the element of A, right? How do I get that? Again, this question is super easy, because pretty much you will get it from the definition. Because we know this X, where does this X come from? It comes from the intersection of A and B. And think about the definition of intersection. What's the definition of intersection?
All elements in A and B.
X is in A and in B. All you have to do is change the symbol to the word, English word and. Okay, so you can say then, following from that, since this X comes from the intersection of A and B, then X is in A and X is in B, right? That's the definition. Maybe because it's the first time we do the proof, I'm going to write down why, the reason here. By the definition of intersection of sets. Is everybody clear how I got this? Yes? Okay. And we are already finished. What did we just prove? I proved every element X from the intersection must be in A, right? Although I actually proved it must also be in B. But their problem did not ask me to prove that. They only asked me to prove, go back to the sentence we wrote down. Every element X of intersection is also in A. Well, I proved it's also in A. So that part is the extra part you got, and which is it's not needed, but I mean, we already got what we have. So it's one sentence, very easy. Okay? So in the whole textbook, they also ask you to prove another one. The intersection of A and B is a subset of B. Pretty much it's exactly the same proof, but you're just going to take the second part, not the first part. Okay. Well, you may think this is just too easy, right? It is very easy. It's just how you're supposed to write it. So, well, first thing, you have to memorize that whenever you want to prove something. And the first sentence you're going to start with is always going to pick something from here. So in your homework, say you want to do this question here. Every element of A and C is an element of B and C. So you're going to pick X, let this element be X. It's going to be from A and C. And you're going to try to show that X is going to be in B and C. And for this last homework question, it will be this element will be your X. It comes from A union B. And you have to show this X is also in C. Okay. The ones you're going to do will not be as easy as the one I have, but it's not, as long as you follow the definition, it's not too difficult. So that is how you prove substance. Well, I have about 3 minutes left. It doesn't seem like I have time to do another example, but if I get cut off, and I will continue next Monday. So I will need to update the homework question I posted on Blackboard, because if I couldn't finish, and I will have to how to prove the second type of question, like how to prove two sets are equal. So I may have to talk about this on next Monday. All right. So the other example, which I said the complicated one, it's on page 273. Example 5.2.2, called the Distributive Law. I definitely won't have time to finish it, but I want to try to finish the one part here. So it wants us to prove for all sets A and B and C, A, B, and C, A union B intersection C is equal to A union B intersection A union C. And from looking at this, it's complicated. But this is the second type of question, how to prove two sets are equal. And remember how we prove two sets are equal? What's our approach? What's our approach that I gave you? How do we prove two sets are equal? One of them is you got to prove these two sets are subset of each other. So you have two steps. Step one to prove the left side of Y is a subset of right. Step two to prove the right side is a subset of left. And in this case, so step one, we're going to prove which one is a subset of which. The left side one, this whole thing, very long one, is a subset. Notice that I changed the equal sign to a subset sign. Is a subset of the right side one. That is our first step. What's the second step? By looking at this, what's our second step? The right side set is also a subset of the left-hand side set, right? So you got to kind of save a lot of space there. At least I would say maybe 8 lines there. So step two, you got to show the right-hand side set is a subset of the left-hand side. After you do both, It guarantees that these two sets are equal. But these two sets are very, very complicated. That's one set, that's another set. And how do we show the left-hand side set is a subset of the other one? That's what we just discussed. How do you show one set is a subset of the other? That's it, okay? So in this case, you will have to show what? What do we start with? You want to show every element of this one.
Your meeting has ended.